Let's just take a minute and take a look at what the sampling distribution looks like whenever we've standardized every slope. So here's our Old Faithful example, and here is the slope of all of the individual values of our samples of 20. So here's all of our slopes. This is our standardized slope. So remember, our standardized slope is our test statistic t, which was just taking the slope over your standard error of the slope or the standard deviation. So this is what your scores look like if I took every single b value and found the standard value for it. It's a t distribution with 18 degrees of freedom. Why? Because our sample size was 20. And remember here, your degrees of freedom is always going to be n minus 2. If you'll notice, when we take a look at the sampling distribution, it does look approximately normally distributed. So, and this sampling distribution it's approximately a t distribution with a degrees of n minus 2 or 18. All right, the next thing we're going to take a look at is using a confidence interval. Now, what exactly is a confidence interval going to estimate in this case? The confidence interval for beta, so remember big beta is going to be the population slope. So the confidence interval for big beta, basically what this is, well, not basically, what this is estimating is your confidence interval gives you a possible range of values. Okay, gives you a possible range of values for the population slope. So remember, whenever we did a confidence interval for means or proportions, the confidence interval gave us an estimate for the population mean, population proportion. This is going to do the exact same thing, only it's going to give us the information for the population slope. What's a range of values where the population slope could actually lie? We're going to use our same exact formula, your statistic, which in this case, think about what that's going to be, your critical value and your standard deviation of your statistic. Now, what exactly is that statistic? That statistic is the slope from one sample regression equation. So remember, here's our population regression equation. Then if I take a sample, okay, maybe this is my sample regression equation. This is my sample regression equation. This is my sample regression equation, okay? So it's the slope from one of those. The critical value is your t-value, since our standard deviation is going to be unknown. And then your standard deviation of the statistic is the same as the standard error of the slope, okay? So this is your t-interval for the slope. So this b, this is your slope from a sample, notice it's little b. Critical t, same exact thing that we did before, just remember your degrees of freedom in this case are going to be n minus 2. And your standard error of your slope, okay, you're going to be given a formula to find the standard error of the slope is going to be your test statistic t over b. All right, now, this specific formula is not on the AP exam formula sheet. So just keep in mind, since it's not on the AP exam formula sheet, the formula sheet in general for confidence intervals, remember it always just says your sample statistic, okay, and then it'll always say plus or minus your critical value times the standard deviation of the statistic, okay? So you just have to know, what do I plug in? In this case, it's the slope, a critical t-value, and the standard error of the slope. Now, how do we find the standard error of the slope? If you're not given that information, there's actually two formulas you can use. Here, this S is going to be your standard deviation of the residuals. Okay, so that's the standard deviation of the residuals, and you'll get that on your graphing calculator every single time. This S of X is your standard deviation of X values, which you can get from your graphing calculator. Square root of n minus 1 is just your sample size of n minus 1. T is your critical value, and that's just, you're going to find your critical value by doing the same thing. You're going to be doing inverse T. Let's say it's a 95% confidence interval, so 0.975, and then your degrees of freedom, just remember, in this case, it's n minus 2, okay? Now, here's something important that will be very helpful. You're going to be doing a lot of computer outputs in this section. Most of them will give you the standard error of the slope and your slope, so that's going to be very, very helpful. Okay, now what exactly is the standard error of the slope means? Remember, that tells us on average how the slope of the sample regression line varies from the slope of the population line. So when I have a whole bunch of different slopes, on average, how different are they from the population regression line? So let's just take a look at an example of creating a confidence interval for the slope. On the previous example, we looked at the results of an experiment designed to see if sitting closer to the front of the classroom causes higher achievement. We looked at the conditions for inference and there was no major violations. So confidence interval, same thing. When you have a confidence interval, all right, you still have to have your conditions. Okay, but most of the time for this, notice how it says no major violations. So we can say that the conditions have been met. Here's a scatter plot for the data and some output from a regression analysis. So here is your output from your regression analysis. This is going to be called a mini-tab output. Notice how it tells you your X and your Y value, score versus row. This is always your Y. This is your X. Now, here's your labels, predictor, coefficient, standard error of the coefficient, T and P. Right away, you can always cross out these values right here. You will never need them, and cross out this value. Just cross them out. You'll never need them. This is always going to represent your Y. Constant is your Y, and your second one is always your X. Now notice how this says row. It matches row on your graph, that's X, and versus row on your title. So coefficient is like coefficient of Y, coefficient of X. So think about Y equals mx plus b for your slope. Coefficient, this is your coefficient of Y. Well, what's kind of the coefficient of Y here? That is your Y-intercept. Okay, I shouldn't use B because that's our slope here. But this is your Y-intercept always. Then this is your standard error. Okay, this is your standard deviation of your Y values. We don't care about these. Now row, think about your equation. If this is X's, look at your equation up here. What comes in front of X is your slope. This piece is always your slope. And then this standard error of the coefficient. So if this was the standard error of the Y-intercepts, which we don't really care about, this is the standard error. And what is this? Standard error of the coefficient. This was the slope. So this right here is your standard error of the slope. Yay, that's exciting that that gave it to us. This is your test statistic T. It's not your critical value. It's your test statistic T. So if you were to find your standardized value, this would be your test statistic T, okay? This p-value, okay, so if this is T, which is negative 1.18, this p-value is the area under the curve here, okay, which is 0.248. Now, keep in mind, this is always two-sided. Okay, this p-value, this probability statement is always two-sided, okay? So just keep that in mind. If you have a one-sided test, you'll have to divide by 2. Now it says, identify the standard error of the slope from the computer output, interpret this in context, calculate the 95% confidence interval for the slope, show your work, interpret the interval in context, and based on your interval, is there convincing evidence that seat location affects scores? So go ahead, try this, and go ahead and see how you do. All right, let's take a look at the answers. So number 1, so we're finding the standard error of the slope. The standard error of the slope is always this piece right here. Okay, standard error of B. So what does that mean? Remember, your standard error of the slope means if you were to do this many times, the slope of the estimated regression line would vary by about 0.942 from the slope of the population regression line. And notice what the last sentence says, predicting test score from row number. So basically you're just adding here what you're predicting, okay? Now the second question is, let's take a look at our confidence interval. Remember, it's B plus or minus your critical T times your standard error of your slope. Well, here's our slope right here. That's already given to us, so I can plug that in pretty easily. Your standard error of your slope is given to us. I can plug that in pretty easily. But how do I find my critical T? Well, here, since there was a total of 28 values, which we were given on the previous question, the degrees of freedom is going to be 28. Since I want a 95% confidence interval, just remember I have 95 and then I have 2.5% below, 2.5% above, and I'm looking always the area to the left. So I'm going to do inverse T of 0.975, degrees of freedom 28. Get that answer and go ahead and plug that in. So now it's just plugging and chugging and making sure that you get that answer. Now remember, this interval right here gives us an estimate of the population slope, negative 3.057 to 0.8228. Okay, so what exactly does that confidence interval tell us? It tells us we are 95% confident that the interval from negative 3.507 to 0.8228 captures the slope of the true regression line. So take a look at that interpretation. Captures the slope of the true regression line relating their test scores and the number of students row X. Okay, so please make sure that you're putting this in context, okay? Those are your important words. So the same words as before, only we're taking a look at the slope of the true regression line, not the true mean or proportion. And what does that mean? Relating what the X and the Y value are in context. So this would be the interpretation of the level. If we were to take many, many samples of 95 of the 100 samples would contain the slope of the true regression line. So it's the same old interpretation. We're just talking about capturing the true slope instead of the true mean and the true proportion. Now, if you take a look at this, take a look at our confidence interval. This confidence interval has 0 right in here somewhere, okay? So if the slope is 0, that means that we can't use the X values to predict Y. So what we can say here is, since that confidence interval contains 0, we don't have enough evidence to say that seat location actually affects the t-scores. So a slope of 0 means there's no relationship. Well, what does that mean? It means that there's no change in y if there's a change in x. So think about that, a slope of 0. So every time you're changing x, y is basically staying the same. That's what your slope of 0 means. All right, let's take a look at the next example below. Go ahead, take a minute, read this, and then we will take a look at some questions on the next page. Okay, if you need more time to read it, go ahead, hit pause, and then we're going to go on to the next page to look at some answers. Now, let's take a look at the graphs that were given from the computer output. So here, the directions say construct and interpret a 99% confidence interval for the slope of the true regression line. Now notice they gave you your regression output, they gave you the residual plot, and they gave you a graph of the residuals. So here, actually in this case, it does not say that your conditions for inference have been met, so you're going to have to do those conditions for inference. Go ahead, try this on your own, and then check your answer on the next slide. Make sure you use your state, plan, do, conclude that we did in all of our other previous confidence interval questions. All right, let's take a look at the example. Number 1, the state is the same. What are we estimating? We're estimating the slope of the true regression line at a 99% confidence level. If the conditions are met, and notice how we're stating the name of the test, we're going to use a t-interval for the slope to estimate B. We're estimating the true population slope here. What are our conditions? So first is linear. The scatter plot was a linear pattern. There's no obvious outliers or curvatures in the residual plot. What's your independence condition? So the independence condition here is knowing that the amount of expelled for one bottle of Diet Coke shouldn't provide us any information about the amount of carbon dioxide expelled for any other bottles. The normal condition, the histogram of the residuals show that there's no skewness or outliers, therefore the data is approximately normal. So that, remember, that's showing that your y values, okay, are approximately normally distributed for every x value. Then your residual plot. Take a look at the residual plot. The residual plot is going to tell us that the variability of the residuals for each mean number of Mentos is roughly the same. So basically that's saying there's very little variability. There's equal amounts above and below the x-axis. And random, the number of Mentos was determined at random for each bottle of Diet Coke. Here's your answer for this portion. Go ahead, take a minute, check it, and if you have questions on that, let me know. Just remember here, this is always your y, this is your x, This is your slope. This is your y-intercept. This is your standard error of the slope. This is your test statistic t, not your critical t, and make sure you always cross this portion out.